Welcome back. This is another video under electric circuit concepts. Today we have a concept problem, and this problem would like to find the maximum power that can be drawn by the resistors in the circuit when connected across the voltage V. So what is the current at the maximum power condition? So as you can see, our resistors, so we're going to call this R1, R2, R3, are given, and A is equal to the value of our resistance. So let's just write it like this. R is equal to A ohms. K is our constant. So these are voltage. So the first thing we want to note is that the power equation is equal to V times I. In our circuit, we notice that we do not have any variables for I, so current is not available to us. However, we do have the total resistance seen by the voltage source and the voltage source V. So thus, we can write I is equal to V over R. Then power becomes V squared over R. So we can go ahead and find the total resistance seen by the voltage source V. And we can start that by combining the parallel combination. So we take that to be R1 in parallel to R2, in parallel with R2. So that's Ka times Ka all over Ka plus Ka. That is equal to Ka squared. We can just write that one time. So Ka squared divided by 2Ka will equal to Ka divided by 2. Now that we combine these, so we can write this as R1 parallel with R2. We can then add these two together. So that means R1 in parallel with R2 plus R3 is equal to Ka all over 2 plus A over K. We can then write our resistance, our total resistance, we can just call that R, is equal to Ka squared plus 2A all over 2K. So we have R, and we know we have V. So in order to find the max power that can be achieved, we have to limit R to the smallest possible value. Take a look. So power is V squared over R. So the maximum power can be achieved is if, let's just write it like this. So power, we take the limit of R going to 0, V squared over R. And as R goes to 0, the power goes to infinity. So let's find the maximum, let's find the smallest value of R that will give the maximum power or give the greatest power. So to do that, we need to find the minimum value of R, and we can do this by taking the partial derivative of our equation R. And the variable will be K. And we can set that equal to 0 and solve for K. So technically we're finding what is our constant K that will produce the smallest value of resistance that will give the largest amount of power. So we can go ahead and take the derivative. So if we see, we take the derivative of our numerator in this case. So that would be 2Ka times the denominator, 2K, minus, take the derivative of the denominator, so that's 2 times the numerator, 2Ka plus 2A, all divided by the denominator squared. And we set that equal to 0. Automatically, we see if we multiply each side by 4K squared, that goes away. If we multiply that side of the equation, just cancel this. Or let's just keep it for the totality of the problem. So what I'm doing is multiplying each side, is multiplying the equation by 4K squared. This cancels out, and 4K squared times 0, 0. And we can divide by 2, and also we can divide by A. So if we divide by A and divide by 2, we get that 2K squared A multiplied by K squared A, and that would be minus 2A is equal to 0. We can go ahead, and that will leave us with K squared A. We can divide by A also, so that would be K squared minus 2, which is equal to 0, and K is equal to the square root of 2. I want to take the positive value, so our constant K is equal to the square root of 2, which when multiplied or times each resistor in the circuit would produce the minimum total value of our resistance. So the power absorbed by the resistors in the circuit, we can then write that as P is equal to V squared over R. So then this is equal to K, we know is the square root of 2. So if we write V squared divided by our equation R, and remember our equation R is as follows. For totality, it's going to be 2K times R all over, let's go look at that, I think it was K2, so that was K squared A plus 2A, yes. And then we can replace K by square root of 2. Why is R there? That should be V squared. So K squared, that would be 2A plus 2A. We simplify that a little bit more. We can go to the simplification, or we can just multiply. Right here, we could go ahead and just multiply by this, which is actually 1. Doing that, we get 4V squared. And down the bottom, we get square root of 2 times 4A. 4 and 4 cancels out, so then we have V squared all over the square root of 2 times A. So the equation that gives the maximum power is as follows. And at the maximum power condition, what is the input current, or what is the maximum input current? What is the input current at the maximum power condition? So now we can find current, because current is, in our case, V over R. Well, we have the power and we have the voltage. So basically we just rearrange the power equation, and we can just use that because we want to find the input current at that condition. So we'd like to include power, and that would be, power in our case would be V squared 2 times A, and we divide that by V. Let's write that a little bit longer, V. I mean, my bad, so that'd be V squared. Well, let's go take a look. V squared. Yep. Divided by V. So cancel out, and we're left with V all over square root of 2 times A. And that would be the input current at the maximum power condition. So this was just a basic concept problem where we used the parallel combination for two resistors. We added both resistors in series. After we did that, the circuit then become VR. We use that to then find the maximum power condition. But before we did that, we had to find the constant K that was multiplied by A, which is our resistance of the resistors. So K was just a constant factor. After we find K, we then go ahead and find the maximum power condition. After finding the maximum power condition, we can then find the current at that time or at that condition. So that's it for today's problem. This was just a simple basic problem, and I'll see you in the next one. Bye.